Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In this lecture, we will learn about graphical representation of cumulative frequency distribution. In the last lecture, we calculated median using a formula, right? Everybody of us knows that formula well by now. Now, in this lecture, we will draw graphs of cumulative frequency distribution, and then using that graph, we will learn how to find the median. Okay. Now, let us start by looking at this table. This is the class of marks, that is 0 to 10 marks are obtained by 5 students, right? 10 to 20 marks are obtained by 3 students. Now, if I ask you how many students have got marks less than 10, you will say 5 students. How many students have got marks less than 20? You will say these 3 and these 5. So, 8 students, which is this cumulative frequency. How many students have got marks less than 30? You will say these 4, 3 and 5. So, 4 plus 3 7 plus 5 12, that is this cumulative frequency. So, if I now look at this cumulative frequency from this perspective, that this is less than type cumulative frequency, that it is giving me the number of students who are less than this upper limit, less than 10, less than 20, less than 30 and so on. Okay. And these are the students who have got less than 100 marks, that is total number of students, that is 53. So, this is less than cumulative frequency. Similarly, we can talk about more than cumulative frequency also. So, this is more than type cumulative frequency. Now, let us look at the lower limit here, 0. So, how many students have got more than 0 marks? You will say all of them, that is 53, right. Now, if I ask you how many students have got more than 10 marks, you will say apart from these 5, everybody else has got more than 10. So, I will subtract 53 minus 5, that is 48 students are such who have got more than 10 marks. Now, this was about more than 10. So, more than 20 if I ask you, you will say apart from these 8 students, everybody else has got more than 20 marks. So, 53 minus this 8, right. So, that is 45 students. Now, more than 30, apart from these, that is how many? 12 students, rest all have got more than 30. So, 53 minus 12, that is 41 have got more than 30 marks, more than 40, right. Now, more than 40, everybody apart from these have got more than 40. So, how many are these? These are 15, right. So, 53 minus 15 this time. 53 minus 15 will give you how much? 50 minus 15 is 35. So, 53 minus 15 is 38. Now, similarly, for the next entry, you will subtract 18 from 53. That is 53 minus 18 will give you 43 minus 8, that is 35. For the next one, you will subtract 22 out of 53. So, it will give you 31 here. For the next one, 53 minus 29. So, it will give you 24, right. For the next one, 53 minus 38, that is 15. For the next one, 53 minus 45, that is 8. So, now there are 8 students who have got more than 90 marks, which is true also, right. So, these are the cumulative frequencies more than type, and these are the cumulative frequencies less than type. So, now if I ask you, let us talk about more than 0. Now, if I ask you more than 0, you will say 53. You will look at the more than frequency, more than type cumulative frequency and say 53. If I ask you more than 40, you will look at this 38, right? Now, if I take these limits, these are lower limits for more than type, you obviously need lower limits. Similarly, for less than type, you require upper limits, right? When you talk about less than 10, less than 20, you require upper limits, right? Now, if I plot this on a graph, okay, if I write, let us say, to start with lower limits, if I write lower limits here on the x axis, that is 0, 10, 20, 30, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, right. So, these are the lower limits that we have, and I write more than cumulative frequencies here, more than cumulative frequencies on y axis. Okay. So, these are the more than cumulative frequencies. Let us divide the y axis like this: 10, 20, 30, 40, 50, 60, 70, right. Now, if I say more than 0, you will say 53. So, 0, 53 is a coordinate for me, right. If I want to plot it on this graph here, where lower limits are on the x axis and more than type cumulative frequency is on y axis, the 0, 53 will be a coordinate for me. Now, if I ask you another question, more than 10, you will say 48. So, this is another coordinate for me. Right. More than 20 was 45. This will give me another coordinate. More than 30, 41, another coordinate. Similarly, 40, we will have 38 here. Okay. So, these are our coordinates. So, if I write the coordinates here itself, that will make it simpler. 0, 53 is a coordinate, 10, 48 is a coordinate, 20, 45 is a coordinate, 30, 41, 40, 38, 50, 35, 60, 31, 70, 24, 80, 15, 98. So, these are the coordinates for my more than type cumulative frequency distribution. So, let us draw these. 0, 53. So, 53 will be somewhere here. Let us say this is the 0, 53 point. Okay. When you are drawing on a graph paper, you will get the exact coordinates. I am drawing the rough diagram here. 10, 48. So, 10, 48 will be somewhere here. Okay. Another coordinate 20, 45. So, 20, 45. Let us say it is here. 30, 41, 30, 41 will be somewhere here. 40, 38, 40, 38, and then 50, 35, 50, 35 is here. 60, 31, 60, and this is, let us say, 31. 70, 24, 70, and somewhere here is 24. So, this is 70, 24. 80, 15, 80, and 15 will be here. So, this is 80, 15 for us. 98. So, 90 and 8 will be, let us say, here. So, these are the coordinates that I obtained for more than type cumulative frequency distribution. Now, I will draw a smooth curve, freehand smooth curve. You need to join these points with a freehand. so that you can draw a smooth curve here, and this curve here is known as ogive. This is the name for this, right? And this is a more than ogive. Now, using the similar logic, we can draw a less than ogive also. How are these helpful for us? We can directly find the median using these ogives, more than ogives or less than ogives, right? In this particular case, we have got a more than ogive, right? Now, what was n, that is number of observations? It was 53. If I divide n by 2, that is 53 by 2, I will get 26.5, right? Now, if I look at 26.5 on the y axis, it will be somewhere here, okay? 26.5 will be somewhere here, and if I draw a line and let it meet the graph, so it will meet graph here, and now if I look at the x axis, so this point here, the abscissa corresponding to this point will give me my median, which in this case will be 66.4 approximately, right? If you draw it on a graph, you will get the exact median. So, corresponding to n by 2 is the cumulative half of this number of observations. So, look for n by 2 and at the y axis, and corresponding to that, right, you draw a straight line here, you will arrive at a point on the graph, and then look at the x axis, that will give you your median, okay? The same thing will happen in case of less than ogive also. For less than ogive, what are the coordinates? We will use the upper limits now, because less than 10 is 5, less than 20 is 8. So, this is 10, 5, 28, 30, 12, 40, 15, 50, 18, 60, 22, right? So, this is 70, 29, 80, 38, 90, 45, 100, 53. So, these are the coordinates that we will use to draw less than ogive, right? So, 10, 5. Now, here what will be there on the x axis? We will have upper limits on the x axis this time, right? Because we are talking about less than type of cumulative frequency distribution. So, something will be lesser than the upper limits, right? So, 10, 5 is my first coordinate. Let us draw here. So, this is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So, these are my upper limits, okay? And here I will have cumulative frequencies, this time less than type, okay? Let it be 10, 20, 30, 40, 50, 60, 70 and so on. So, the first coordinate that I have here is 10, 5. So, 10, 5 will be somewhere here. Next 28. So, 20 and 8 will be somewhere here, okay? 30, 12. So, 30 and 12 will be here. So, this is the next coordinate, okay? Now, I am drawing on the same graph here. We can draw it on the different graph and then we will draw on the same graph also. So, let us draw it on the different graph first. So, the coordinates are 10, 5, 28, 30, 12. 10, 5, 28, 30, 12, right? Another coordinate 40, 15, 40, 15 will be here. Next coordinate is 50, 18. So, 50, 18 will be here. 60, 22, 60 and 22 will be somewhere here. 70, 29, 70 and 29. Let it be here. 80, 38. This is 80 and this is 38. Right? 90, 45. So this is 90 and this is 45. So the point will be here. And 153. So let it be 53. So the point will be somewhere here. Now again, this smooth curve. Join these points, right? And this curve here is less than ogive. Similarly, in this also we can find the median corresponding to n by 2. So 26.5. Let us say it is here. So if I join this with the graph and look at the abscissa corresponding to this point, I will arrive at the median once again, which is same 66.4. Now one other thing that I could have done is I could have drawn this less than ogive on the same graph that I was drawing here, right? If I would have drawn this graph on this graph, then the ogive would be something like this, and this less than ogive will also pass through this point. So when you draw both the ogives on the same graph, the point of intersection, the abscissa corresponding to this point of intersection will give you the median. I hope you understood what I am trying to say here. Like, one, you can draw more than ogive, right, using the more than cumulative frequency. Another thing that you can draw is less than ogive. In these independent ogives, what you can do is you can find n by 2 on y axis, and corresponding to that point, which if you draw a parallel line to x axis, you will arrive at a point on the graph, and corresponding to that, the abscissa of that point will give you the median. Now if you draw both the ogives on the same graph here, this point of intersection will give you the median. How? The abscissa of this point of intersection will tell you the median, which will be same, right? So I have given you 3 ways to calculate, find median using the graphs: less than ogive, more than ogive, independently, right, and by drawing both the ogives on the same graph and using the point of intersections abscissa, right.